This is SnipeFlip. I tell it exactly what I'm looking for, it searches Kleinanzeigen, reads every listing that comes back and gives each one a score out of 100. Then I look at the ones above 70. This is one of them, 45 euros for a model that normally sells for 80 to 100. It's a TI-inspired CX2T graphing calculator. I was hunting a graphing calculator, a TI-inspired CX2T, which costs around 100 euros. This is a boring object. It is also one of the best possible objects to hunt, and the reason has nothing to do with the calculator. Nobody who buys one chose it. Schools and universities prescribe the exact model. If your course requires that machine, a cheaper one that does identical mathematics is not an option. So every year there are people who need one specific thing at one specific time, and there are people who just finished school and have that exact thing sitting in a drawer. SnipeFlip helps me to define and look for products on eBay Kleinanzeigen, which is basically Craigslist in Germany. On eBay Kleinanzeigen, I was looking for the exact same calculator, and here you can see that the pricing is around 80 to 100 euros for a used one, but sometimes it can go as low as 50. If we look at Amazon, we can see that the same product is priced around 170 euros for a new one, but used, they go for around 105. This is SnipeFlip. It watches Kleinanzeigen for the specific things I'm hunting, it scores every listing from 0 to 100, and it only wakes me up when something is actually worth looking at. Today I'm putting it on my fresh server from nothing and running it until that notification arrives. The problem with used marketplaces isn't that there are no good deals, it's that good deals last about 20 minutes. So you have three options. You refresh manually, which costs you your day, you accept that you'll miss most of it, or you write something that watches for you. I wrote the third one, and I want to be straight about what that means. This is one platform. Low frequency, one user, me. Kleinanzeigen's terms of use restrict automated access, and I'm not going to pretend otherwise. What I'm showing you is the architecture, how the scheduling works, how the filtering works, how the scoring works, how it reaches my phone. What I'm not showing you is how to get around anything. That part stays out of the video and out of the written guide. If you build something like this, read the terms of whatever you pointed at first. They're all different, and some of them are a lot stricter than this one. 5 phases. Here's the whole thing before we start. 1. The server. PostgreSQL, Node, a process manager, Nginx, Claude Code does the setup, I watch. 2. Defining the hunt. What am I looking for, what am I definitely not looking for, and how far am I willing to drive? 3. The collection loop. Every 15 minutes with a log so it can't trip over itself. 4. The filter chain. This is where the interesting part is, because the AI does much less here than you'd expect. 5. The alert. Telegram, web push, and a live feed over WebSockets. Then I'll also show you the things which didn't work out. Stay for that part. It's more useful than the parts that worked. Now what I'm going to do, I'm going to use my PowerShell window right here and access my server. Then I'm going to run Claude Code on my server. And then I'm going to tell it to set up the following repository as a project on the server. Here's my GitHub token. Of course, I'm going to revoke the token as soon as I've cloned the project onto my server. And we're going to set the mode to auto, so we don't have to set any permissions or provide Claude with any permissions after asking us. Claude is now setting up the repository on the server. We're going to run SnipeFlip using PM2 on the server, Docker with Postgres, localhost. We'll be using Nginx and a domain, which is going to be snipeflip.com. I'm going to tell Claude Code now to use all the existing information except for the Claude AI API key, which I just generated. And now we should be good to go. Instead of a Claude AI API key, we need a DeepSeek API key, which I'm going to generate now. So Claude just asked which hostname should the Nginx vhost serve. I told it to use snipeflip.com, and the scrapers AI scoring calls api.deepseek.com with DeepSeek API key. So we're going to use the DeepSeek API key I just generated. Now we should be good to go. So SnipeFlip is set up and running from my home directory, Damjan SnipeFlip. There is currently one blocker, the domain. You picked snipeflip.com, but it currently resolves to 216.198.79.1 to Vercel. Certbot cannot issue a certificate until you repoint the A records for snipeflip.com and www.snipeflip.com, and doing so moves the site of Vercel. So let's do that. First, what I'm going to do, I'm going to fix the www first. Now we need to set the CNAME record for www to snipeflip.com. DNS is fully propagated and the pre-check now resolves both names to this server. So this command is the one I need to run myself, and we're going to use the separate window and use my account with sudo rights. Everything's in place. We can now use snipeflip.com to access SnipeFlip. The part I want to point out is the process layout, because it's the thing that broke most often. 3 separate processes. The WebSocket server on port 3002, the web app on port 3003, and the scraper worker on its own. They're not one process, and the order matters. The WebSocket has to be up before the scraper tries to connect to it. There's a comment in my own config file that says exactly that, in capital letters, because I got it wrong enough times to write it down. Memory limits: 200 megabytes for the WebSocket, 500 for the web app, 1 gigabyte for the scraper. The scraper gets the most because it holds parsed HTML in memory while it works through a batch. Phase 2, defining the hunt. This is the part people get wrong, and it has nothing to do with AI. A track product isn't just a search term, it's 4 things. The name, TI-Nspire CX2T-CAS, not calculator, not graphing calculator. The exact model, because the exact model is what's prescribed. Required keywords, words that must appear or it isn't the thing. Excluded keywords, and this is the important one. Search for a calculator on eBay Kleinanzeigen and most what comes back are cases, covers, spare parts and units sold as defective. Those aren't near misses. They're a different product category that happens to share the name. So the exclusion list is Hülle, case, cover, Reparatur, Ersatzteil, defect. Taschenrechner is the German word for calculator. Tasche is inside Taschenrechner. So a substring match against my own exclusion list was silently throwing away every single listing for the exact product I was hunting. The filter designed to remove accessories was removing the thing itself. The fix is a word boundary matching instead of a substring matching. There's a comment above that function in my repository explaining it with those 2 exact words, because I never want to debug that again. German builds compound nouns the way other languages build sentences. If you filter German text by substring, you will eventually delete your own product. Inside the project repository, you will find a seed file which contains all the product information you need to start your first search. There's 3 calculator models which you can use to find suitable deals. That's 1 hunt defined. Phase 3, the collection loop. Every 15 minutes, 5 search links in parallel. Maximum. First thing is the job is a mutex, a boolean and a timestamp. If the previous run is still going, this one logs how long the old one has been running and exits. It does not queue. It does not run alongside. It skips. That sounds obvious written down. It was not obvious at 3 in the morning when 2 overlapping jobs were both writing the same listings and the logs made no sense at all. Then deduplication. And this is a batch operation on purpose. Every listing has an external ID. Before doing anything else, the job pulls every external ID it already knows in a single query, updates the last seen timestamp on the ones that already exist, and keeps only what's genuinely new. The reason is boring and important. 50 results per search link. Times 5 links times 96 runs a day. If you check those one at a time, you've built a denial of service against your own database. Only the new ones go onto the detailed scraper. 3 at a time, 500 milliseconds between batches, 30-second timeout. Those 3 numbers are the whole ethics of this thing. It's a budget, not a race. Phase 4, the filter chain. Here's where I expected the AI to do the work. It doesn't. Stage 1 is deterministic. No model, no API call, no cost. Excluded keywords with word boundaries, accessory patterns, because case for X is not X. Required keywords strictly, and a language check. Most of what comes in dies here. There's a comment in that file that I wrote for myself, and it's the honest summary of this whole project. It says this function is the main filter, and it has to be strict because no AI check follows anymore. That word is the story. I started this project with a language model evaluating every single listing. Then I moved to DeepSeek because the volume made the bill uncomfortable. Then I tried image analysis, so it could judge condition from photos, and I turned that off twice because the model I'd switched to doesn't do images. And at the end of all that, that thing that actually keeps my notifications clean is a regular expression that understands German word boundaries. Stage 2 is where the model still earns its place. Everything that survived stage 1 gets a structured evaluation, condition, completeness, and for a calculator, that means the cable, the cover, the manual. Whether the price makes sense for what's described. Seller signals from the detail page. Out comes a score from 0 to 100 with a reason attached. Twice a day at 8 and 1800, a separate job recalculates the average price per product from what it has actually seen. So cheap means cheap compared to this market this month, not compared to a number I typed in once. Stage 4 is the threshold. 50 and above gets a notification, everything else lands in the feed and waits for me. 80 and up is the one I actually get out of my chair for. Phase 5, the alert. 2 channels, Telegram because it's the one I actually read, and web push for the browser. The notification carries the score, the price, the distance, and the reason the model gave. Not just a link. If I have to open the app to decide whether to open the app, the whole thing has failed. Meanwhile, the dashboard updates over WebSockets. New listings come in, it appears, score gets attached, the badge changes, no polling. And every listing keeps a price history. Same item, relisted cheaper 3 days later. That's visible, and that's usually the moment to message the seller. That's the loop, server to phone. The other thing it turned out to be for. I built this to flip calculators. Then a friend of mine wanted to buy a Mac. I told him to get an M1 rather than anything newer. So we put it in. Same for fields, name, required keywords, excluded keywords, radius. No code changes, it's a different product, not a different problem. He then ended up comparing multiple devices and actually ended up with one with the original packaging and everything in place when it comes down to accessories. And that's the point where I stopped calling it a reselling tool. Flipping calculators is what I built it for. Helping somebody buy one good used machine instead of a new one is what it's actually best at. Same system, and the second use is the one I defend in public. So let's filter the listings we found, and let's say we want to look at 70 plus. This one's a pretty good deal. We have the TI Nspire CX2T calculator with a scoring of 72 out of 100 with a price at 45 euros. The LCD is working, and we have the case as well. And some cables. So we have a potential profit of 35 euros if we buy this one at 45 euros and sell it for, let's say, 80. Now we could immediately generate a message for the seller and send this one via Kleinanzeigen. Now let's talk about the failures. 5 things I got wrong. In roughly the order I got them wrong. 1. I scored listings before I had the listings. For a while, the AI evaluation ran before the detail page was fetched, which means the model was scoring a title and a thumbnail and nothing else, and then confidently telling me about the condition of an item it had never seen described. The fix is one commit. Scrape the details first, then evaluate. The scores got noticeably better for free, and no model was involved in that improvement at all. 2. The page moved under me. There is a function in this repository whose only job is to get the images out of a listing. It has 4 different ways of doing that. First, it looks for structured data inside the gallery elements. If that comes back empty, it goes after CSS background images. If that's empty too, it falls back to the general product schema on the page. And if all 3 fail, it scrapes image tags and their lazy loading attributes directly. I didn't design that, it accumulated. Every layer is a morning where something that worked yesterday returned an empty array. 3. Vision disabled twice. I built image analysis so the scoring could look at photos and judge condition, which for a use calculator is mostly about the screen and the keypad, so it seemed worth having. Then I switched the AI provider for cost reasons. The new provider doesn't support image input. There are 2 commits weeks apart, both turning vision off. The second one exists because I forgot about the first. 4. Port collisions. 5 commits with the same error in them. Robust PM2 restart, port cleanup in the deploy script, retry logic in the WebSocket server, graceful shutdown, sequential, service start. That is not one bug. That's one bug I fixed 4 times badly before fixing it properly. The actual fix was accepting that 3 processes needed a defined start order and a kill timeout, not clever retry logic. 5. The build tool. TurboPack for production builds with standalone output. Disabled. The last one, well, it's the committed.env file. I mean, what's there to say? Framework. 3 rules. They are the reusable part and none of them are specific to calculators or to marketplaces. 1. Deterministic first, model second. Every filter you can write as a rule, write as a rule. The model gets what's left. It's cheaper, it's faster, it's testable. And when it goes wrong, you can read the line that did it. A regular expression has never hallucinated a reason. It will happily eat your entire product category, but it will do it in a way you can find. 2. Assume the page will change. If your input comes from someone else's website, it's not an API and it will not warn you. Write the extraction as a chain of fallbacks from the start and make an empty result loud. Silent empty arrays are the worst failure mode there is, because everything keeps running and the quality just quietly drops. 4 fallback levels for one image is not over-engineering, it's what a year of Tuesdays looks like. 3. Every automated fetch needs a budget. Concurrency limits. Delays between batches, a scheduling interval, and a lock so runs can't overlap. Not because someone forces you to, but because a system that stays under the radar keeps working. And a system that races gets blocked, and then you have nothing. Those 3 rules are why the AI in this AI project ended up doing less than it did on day 1. That's not a failure of the model, that's what the job actually needed. Resources. Everything is in the description. The full written guide, architecture, the process layout, the filter chain, the scheduling numbers, and a section on platform terms that you should read before pointing this at anything. The repository. There is a link to the repository which I set to public as well, and the self-hosting video, if you want the server underneath this one, is on the end card. Here's what I actually take away from this one. I set out to build an AI tool and I ended up building a filtering system with a language model in the middle of it, doing one job it's genuinely good at. Behind rules that don't need it. And the other half of it, a calculator that someone needed for 2 years and hasn't touched since, is a perfectly good calculator. Somebody is starting that course in September and could end up using it. A 5-year-old Mac is still a fast computer. None of that needs to be manufactured again. It needs to be found. That's a search problem, and search problems are the kind of thing you can put on a server and forget about. That's not the reason I built this, it's just a reason it was worth finishing. My name is Damjan. Thank you very much for watching, and subscribe for more AI and development tutorials. See you in the next video.